There we go. So I told you guys, look at the code and see if you can make general sense out of it. I'm guessing that most of you acknowledge that it does make some sense. I would hope so. Um, it doesn't matter if you don't know exactly what's going on. That's what I'm here for. But I think you should have a general idea. So let's change topics slightly, and we're going to talk about inheritance. Now, forget programming. Let's just talk regular inheritance, right? What do you understand when you hear inheritance? When you hear that term in the real world, inheritance, what goes through your mind?
What traits you get for your man, your pa?
Okay, all right. Basically, that's it, right? And it doesn't have to be from your mom or dad, right? It could be from some loved one. It could be your uncle, your aunt, or maybe just somebody who um, really like wanted to help you out, and they knew that when they died, they could definitely help you out by giving you whatever they had. The point is, somebody had assets. Could be liquid assets, could be cash, or it could be uh, tangible assets, and they essentially legally passed on those things to you. That's basically inheritance, right? Of course, there are a lot of additional legal things associated with that. We're going at using the most basic description of what inheritance is all about. That principle, for the most part, holds true in programming. With programming, I want you to imagine like this. Now, you have to, the reason why I asked you that question before, right? When I was here, remember this? And I said, you already know what a linked list can do. You know what a stack should do. And I said, look at this diagram. And I said, if you notice, a stack can be drawn to look like a linked list, but we just have to restrict some of the functionality. And we said, all right, the only functions we can use from a linked list would be inserted front, remove from front, and is empty. The rest we can remove. Okay, so I said that means technically, if somebody gives me the linked list class, I can build myself a stack class, right? I would take the full code from the linked list, right? Let me just show you, man. Let me just go show you. Otherwise, blah 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 blah. I would just come here, right? I would highlight this from line 114 to 140. I'd highlight this and delete this. Okay. I'd keep this and I would call this pop. I would keep this and I'd call it push. I would highlight this and I would delete that. Um, what else? Let me add this person. Uh, oh my God, your sugar mama. Oh, geez. I don't even know. Oh, you're answering a question about inheritance. I was like, what? I didn't even know what that was responding to. Okay, yes, Azer, I have. I'm not familiar. Well, I understand what you're saying, but I don't know if you have experience in that, Azer, that your sugar mama is giving you stuff inheritance wise. So we shall assume that Azer is well versed in this concept of sugar mama. All right. We will not prod any more into his personal life to find out just how well he knows about this. We'll just take his word for it, guys, that yes, you can also receive an inheritance from your sugar mama. All right, so let's continue. All right. I think if Ezra's camera was on, he would be glowing right now. Sir, you have no, sir, I have no sugar mama. Okay. The only sugar mama that exists right now in this entire classroom is for Azo. Azo has a sugar mama apparently, and he knows. He's talking from experience, damn it. Oh, I'm a sugar daddy. All right. Thank you for that, Chad. Apparently, Chad knows about this as well. All right. All right. That's a good reminder. I know what to add on to my resume next time. Okay. So let's. So again, this is my linked list. If I want to convert this to a stack, I would come here. See, I want to convert my linked list to a stack. I'll come here. I'll change this from class list. I'll change it to stack. Change this to stack. Stack. Change this word to push. Delete this. Call this pop. Delete this. Keep this. Delete this. Then those same prototypes that I deleted, I would delete the corresponding implementation. And that's it. You now have yourself a linked list. All right? Do you think what I just explained to you, the steps that I just explained to you, delete the functions you don't want, and then rename those things? And do you think that's an example of inheritance? Do you think what I just explained to you would qualify as an example of inheritance?
The one that included in the other class, then you have access to the functions the first class had. That's inheritance.
So what I just described would not be considered inheritance. Is that what you're saying?
Yeah, wouldn't be described as inheritance.
Let me just check the chat to see if anybody agrees with what was just said, because I asked the question. Come on, man. Sir, oh my God. Still talking about sugar daddy and whatever. Let's see, what does Zion say? Sir, how sir will be a sugar daddy when you be just...
Raise it up, please, raise it.
Ah! That's good. Zion, dude. Zion is on fire. All right. Okay. So it's a good point. That's a good point. That's why I have I've given up that.
Because what you did earlier just modified the first class, right, sir? The first list that is.
Say that again.
What you did earlier just modified according to list that is, right?
Like I would rename it. Like okay. So what I was saying is I'll take list.h, copy it, right?
Yeah.
Just literally copy it and rename the file. Instead of calling it list.h, I'll call it stack.h, right? And then I'll change the class name from list to stack. I would keep the functions insert the front, remove from front is empty. And I would delete everything else. And I would rename insert the front to push. I would rename remove from front to pop. And that's it. Would you consider what I just explained to you, those actions that I just explained to you, would you consider that as describing inheritance?
No, because if you do inheritance, you wouldn't need to do a copy and paste everything. You just build it one time and then include it or import it, and then you have access to whatever is built.
So what I just explained to you is definitely not an example of inheritance. All right, because
so much unuseful.
You're doing a lot more work, unnecessary work. All right, you're doing a lot of unnecessary work. Whereas with inheritance, the whole point of inheritance, this is the whole point, right? You see a class that has a lot of the functionality that you need. That's the first thing. You recognize there's a class that you have access to that has a lot of the functionality that you need. And you think, okay, I can rebuild those functions from scratch, like what I just talked to you about, like build it from scratch, or I can inherit from that class, which, just like what I said in the real world, if I inherit from a class, just imagine you get everything from that class. So if I get everything from that class, then there's no need for me to rewrite anything. I get access to all of these things as if though I wrote it myself, but I actually didn't have to. That's what inheritance is. There's a class you see that has a lot of the functions you need, and you think, heck, I don't want to have to rewrite these things. This class has majority of what I want. I'm just going to inherit from it, and I'm going to end up getting all of those functions, and then ones that the functions that I need that class does not have, those I'm going to write. No problem. I'm going to add those. But overall, majority of the ones that I needed, I got from that class. That's what inheritance is all about. What I described earlier with the list class and you renaming this and then you copy this and you delete this, that works. Don't misunderstand what I just said. That works, but that is not inheritance. What you're looking at on your screen right now, this is an example of inheritance. This, let me just show you. I'm going to go to the next slide. Hold on. So these two pages together, this is your full stack class. All right? This is the full stack class. How was I able to build a full stack class with such minimal code? Again, inheritance should be your response. So let's look at how this works. So let me just check the chat in case people are confused. Remember, if you're confused, you can always unmute and let me know what the issue is. Because like I don't know why when I go to chat somehow like just copy the code and name it something else. No, that's copy the code and rename it something else is not a good approach. Because if that code original had lots of errors and they fixed the original code, you don't get the fixed version. All right, you literally copied the errors, so you have to now fix your code. It just adds a whole lot of problems. It's better that you inherit, and if the class you inherit from had problems and the person fixed that class, automatically you're going to be working with the fixed version. Okay, so let's go through this and see how this stack class was built using inheritance. I'm going to ask you a bunch of questions and try your best to answer without overthinking, because some people try to really overthink and then they can't even answer the thing, right? Okay. Sorry, just checking my cell phone. Why do you think line 6 exists in this particular code snippet that you're looking at? What's the purpose of line 6?
So that's the import data for the header. The same file you have access to functions. So you need to define it so you can import it and bring it into the other file.
So why that file exactly am I trying to include in my, because remember this file, look at it, this file is stack.h, right? So inside of my stack.h, line 6 says found and include list.h. So my question is, why specifically did I do that?
For inheritance.
Yes, true for inheritance. Why?
Because you're calling his functions on this class, something like that.
Okay, because I'm about to tell the compiler, hey compiler, there's a class that has some functions or has things that I want to inherit from it. And the compiler obviously is going to ask you, okay, which class? Number one, which class? Number two, where's the code for that class? So that's what line 6 is all about. Line 6 is including list.h, which will form the basis of your inheritance process. You need to tell the compiler which class you're going to inherit from. You can't say, I'm going to inherit from a class. Which class? Where's the code for that class? So that's what line 6 is all about. All right. So since we're inheriting from list.h, sorry, from the list class, we need to include list.h. So that's line 6. What is line 8? What's the purpose of line 8 in this whole thing?
Create a template. Template class.
Okay. So as soon as I see line 8, I know immediately I know the class that I'm about to look at is a template class, which means that this is not a, how can I say? It's not a real class per se. It has missing parts. Now, what did the authors of this book or these slides decide to name their type?
Stack type.
Stack type. Did they have to change it to stack type, or could they have used no type?
Yeah, they could have used no type.
Stack type because that was stuck.
Okay, so you're saying because
I
it's a
think- I
stack
think
class,
use
we
no
had to
type,
name
but
it
would-
stack type. Is that what you're saying?
Well, it could be any
I
name,
think it
sir.
could have been no
Let
type,
us say
but it
this
wouldn't have
does
been.
Yeah.
It could be any
Could have
name.
been any name called cut.
Just to,
Rabbit.
just to try keep
All right,
Boom.
so this could have been called cow type, correct?
Hell.
Yes,
just to keep it
Right. Remember, this is user defined or programmer defined. You choose what you want to name this thing. The reason why they named this stack type, it's not because it's required because you're building a stack has to be called stack type. It's only to make your code readable so that whoever is looking at your code will understand at a glance stack type. This is an undefined type, but it's referring to a stack class. If you had named it chicken type, they would also still know that this is an undefined type. But the word chicken would be misleading because they're thinking chicken type. Why did they name it chicken type? You understand? So this is something you choose, but it should also be indicative of what the heck you're trying to represent. Does that make sense? ¿Entiendes?
Sí, entiendes.
sir.
Okay. All right. Now, so now we know what line 6 is all about. We know what line 8 is all about. And line 9. So what's happening in line 9?
This is new, sir.
Well, half of it is new. The other half is not new.
Sir,
The class stop.
the same
I'm
class.
building a class called stack, right?
Yeah, build a class.
I'm building a class called stack. So
The same
before-
class where to put it as a private data member, so you couldn't have access inside that class.
before this was what a regular class would look like, right? You just have this. All right. And you would say, oh, you're building a class called stack. All right. That hasn't changed. You're still building a class called stack. The class is called stack. Nothing has changed. The only difference now is you'll notice inclusion of that guy and this guy. Is that clear? Now, as soon as you see a colon after the name of a class, that means immediately you should know that this class is doing inheritance. All right? Class stack, basically you're telling the compiler, class stack should be built using inheritance. That's what that is doing. What you see after the colon is the name of the class from which you would like to build your stack. So the colon says that I am about to build my class stack using inheritance. That's what the colon means. The thing after the colon is the name of the class from which you're going to inherit. This means inheritance. This is the name of the class from which you're going to inherit. Now, if list was a regular class, I would have just written this. I would have just written class stack. And I'd be on my merry way, right? That's all I would do. Put the colon, and I put the name of the class. But you and I both know that class list is not a regular class. It's a template class. So I need to also indicate that this is a template class. That's why I have to put the angle brackets. If list was a regular class, not a template class, I would just put private list, done, and go on. Since this is a template class, I have to put this. So far, what I'm saying, does it make sense to you?
Sir, why is it private? So that nobody else could access it?
Okay, now that I'm going to explain it right now, but I need for you to understand the rest because this
Okay.
part will be tricky. This part will be tricky. So I need for you to understand the role of this guy and this part. Does that make sense to everybody?
Yes, sir.
Okay.
Yes, sir.
All right. So now I'm about to explain to you what this is, right? Now, in this example, they chose private. You could have put public. You could have put protected. You notice these are my what? These three represent my what? What's the official term for these three guys?
Access specifier.
Access specifiers, right? So now in this particular case, I have chosen the keyword private. And again, I could have chosen public, protected. Each one has a precise effect. They don't have the same effect, all right? This does not change what you receive when you do inheritance. That's the first thing I want you to understand. Choosing one of these does not change what you receive, all right? You will still receive the same things. These determine where those things that you receive will be placed. But let me try my best to explain this thing to you now. All right? All right, so let's how can I explain this thing to you? All right. So think of it like this, right? This is your house. All right. All right. And then so this is Azer's house. All right. Hold on.
Nice, sir.
You're welcome. All right. So this is Azer's house. I don't know how to draw a dump truck, but let's pretend this is. How do you draw a dump truck? This. All right, gotta draw the grills, man. All right. So this is a dump truck, right? And this dump truck contains, sorry, there's sugar, items. All right. Now, Azer's sugar mama died. All right. So let's just absorb that for a second. Just let's be calm. I know it's sad. Okay.
I like this
Azer's
example.
sugar mama died, and Azer's sugar mama left a will and said that Azer should receive everything that she has. All right. So now they're executing the will, and this big dump truck has come full to the top with all of Azer's sugar mama's items, right? Everything, furniture, everything. All right. It's here. And now the guy jumped out of this truck. There he is, right? Got big muscles. Oh my God. It's not muscles. Oh, anyway. So big strong dude, right? And he's asking Azer, right?
Nice.
This is Azer. Azer doesn't
Nice
have
one, sir.
Azer does not have big muscles. Let's just be clear about that, right? So he asks Azer. Well, first of all, he's shocked that Azer is receiving all of this, but he decides not to ask and be rude. But anyway, that's what he was thinking. He said, Azer, where am I supposed to put this stuff that I just received? I'm bringing for you. So now Azer has 3 choices, right? Azer can say public, which should mean basically put it on his front lawn, like in front of his house. All right? So this is his yard, like that. Okay, this is yard. And basically, if he chose public, it means put everything here. Or if he says private, that means the dump truck is going to come into the yard and he's going to dump all of these things inside of Azer's house. Okay. Protected. I'm not going to talk about protected yet. It's a little bit more advanced, and I don't want to confuse you yet about protected. Right now, the 2 key ones I want you to think about would be public and private. So remember, when you do inheritance, you don't get to choose or pick what you want. Inheritance means you get every single thing from that person. That's the first important point. You get every single thing that person had, you're going to get it. Doesn't matter if you were doing private inheritance or public inheritance. The only difference between this and protected, right? The only difference is where those items will be placed. So private means take all of these things and put it in my house. So it's like inside of my house. Private. Nobody can see it. Nobody knows I got it. Nobody knows I got it, right? All right, because Azer doesn't want people to know about his sugar mama, right? Because that's kind of weird. So he's just trying to keep this house hush. So private means put everything inside of the house. Nobody knows. He knows. He has it. Public means, all right, that Azer is like damn proud apparently, right? I don't know why, but he's very proud of the fact that he received all of these items. So he's dumping all of this stuff on his front lawn. Okay. Now, what's the difference between these two? They still, both cases, they still get the same items. What do you think will be the ultimate effect between these two? Who would like to tell me?
So once again at Azure house, all the Azure have or Azure, since the Azure's house, only here have access to it once they're in your house. And if you left it out publicly, then anybody could just go up on the street side and take it from them.
Let's pretend they can't steal it. Let's add that little caveat that they can't steal from you, but they can definitely what?
Use it.
Use it. They can use it, right? So they can use it. They can't steal from, but they can use it. All right. So
Rip
this will end in
secured
like
PS5.
10 minutes. Okay. So that's the difference. Do you understand what I just explained to you? Now you're probably thinking, hopefully this will stick in your head, right? Every time you think of inheritance, just think about Azer and think about this sugar mama and just think about this diagram. If you do,
Sir.
this will make a lot of sense to you. So number 1 rule is this, right? Number 1 rule. When you do inheritance, what do you receive? What do you receive when you do inheritance? Always, what do you receive?
Everything.
Every single thing. What about private members of a class?
Everything.
Everything. What about public members of a class?
All.
What about protected members of a class?
Everything.
So what happens when you choose private or public here?
I guess no difference.
No. There's a difference. What is it?
The difference is once you set it as private, then you have to put it in the private part of the code.
Okay. And public means?
Then you have these set publicly.
Okay. Let's see what the effect of that is. All right. So let me try to see how I can draw this thing, man. How can I do this now?
There are functions outside the class that wouldn't have access to the functions of this class.
Let's do this. Let's pretend this is main. I'm going to write main. This is main. So we have this right now going, right? I'm going to build myself a stack object. How do I build a stack object? How do you build a stack object?
Call that same function push, sir.
You build a stack object by calling the push function. How do you write the code to build a stack object in your main?
Name of the class.
All right, so stack. And I know that stack is a template, so I gotta
Stack
put
type.
this. And let's pretend we're building a stack of ints, right? I'm gonna call it
Yes.
Okay. Now, because I did inheritance, that means I got whose constructor? I got lists constructor as well, correct? And list constructor wanted what? What did list constructor want from you? Anything?
First and last.
Did list constructor ever want anything from you guys?
No.
No. Okay, so that means I can remove this. And then I can just do come here. And I just built myself a stack object, right? Now I can do this. I can say, can I do this? Oh, let me ask you this question. So we already know this guy was built using inheritance. Yes or no? Yes. Who did he inherit from? List. What did I say happens during inheritance? Do you receive some of the items from the class or you receive everything?
Everything.
Everything. You receive everything. That, let me just show you. Let me just show you what I mean by everything. Let me just show you what I mean by everything. Everything means every function that was private, you got. Every data member that was private, you got. Anything that was public, you got. If you had anything that was protected, you got. Every single thing. All right? Every single thing. Every single thing you got. So all of this, these two private, this is private, all of this, it's yours. It's yours. All right? So now, going back to that, it's yours. Now, so now, with that said, can I write this? So this is my first question, my first important question. Can I do this? S dot insert at front. Yes or no? Come on, guys. Can I do that? Yes or no?
No,
Why?
because
Hold
your
up.
stack
Does stack not have function insert at the front?
in directly no, but indirectly yes.
Yes.
Wait, so if he has it, why can't I call it then? I told you with
Because-
inheritance, you get everything. Do I have it?
Yes.
Why can't I do that? then?
Because it's private, sir.
What do you mean it's private? Was it private inside of the list class? Was insert at front private in the list class?
No,
Go
but
back to the list class.
private.
Imagine the list class.
Actually,
Go back to the list
it's-
class. Was function insert at front in the list class declared as public or private?
Public.
Public. Okay. And you got that function, yes or no?
Yes.
Okay. Can I do this code?
Yes.
Yes, you can.
How many people say no?
Don't we have to put it into the stack class?
What do you mean put it in the stack class?
Oh, wait.
It's
I
there.
think no.
Like
Once you do inheritance, you see this one line? Look. You see this line? Hold on one
I
second.
gets
guys.
everything. Oh yes.
One second.
Two minutes remaining, sir.
Yeah.
They never cut off the net, that's why.
Them,
They
the
started.
mom of the leech off net. I had that though. Somebody with a fried fish.
Okay, sorry about that.
Sir?
Yeah, sorry about that. Due to a phone call. Okay. I don't know why people keep. If I don't answer, they keep on calling and calling and calling and calling. Oh my god! All right. Anyway,
Put your phone in airplane mode, sir.
I should do that. All right. So this will end in 1 minute. You guys want me to just end off when the class ends, or you want me to just finish off explaining this thing when, like another 5 minutes after the session ends? What do you want?
Explain, sir.
Okay. All right. So looking at this is an illegal call. This is illegal. All right. And the reason why this is illegal, it's not because this function does not exist in the stack class. This function is 100% inside of the stack class. Okay, it's there. The reason why we can't call this function, it's because of this. So again, just letting you know, guys know when this session ends, I'll restart it just to finish this explanation and then we'll end off. All right. So it's because of this word, private. What that word private said was, take all the things you got from list, right? Remember, you get everything. The big dump truck came, but you said put everything you got from that dump truck and put it in the private section of the stack class. So pretend that the stack class has a private section, all right? So that means insert at front, insert at back, remove from front, all of those things that were
She has Ben? I think Ben was a guitar or something. Why you taking a class?
I have joined.
All right, let me continue with this. for more people to come in and then. Good to go. All right, so. All right, so let's continue where we left off. All right, share screen. Okay, so back to this. We just built a stack object, and I told you because we did inheritance, right? We did inheritance, so that means we said stack is built from everything from list. So everything from list, all the public functions, all the private functions, all the private data members, everything you got, you said take everything and dump it in the private section of my class. So you're not seeing it, but just pretend stack had a private section, which it does, you're just not seeing it. And all those functions, insert at front, insert at back, remove from front, remove from back, is empty, print, all of those functions got dumped into the private section of the stack class. So just imagine like that, right? If these were private, could you call this function? No, you would not be able to call this function. Even though the function is within your class, even though the function is within your class, you cannot call it. You cannot call any of these because they are private. Now, how can I change this? What if I had done this and I changed this to public? One word change, and let's see what the effect is. So again, I built my stack object. All right, and then what I'm going to do is I'm going to say can I do this? Can I do this now?
Yes,
Why?
because all of the functions were set on the public.
So by just changing this one word public, that means everything you got from list got placed into the public section of your class, right? So now all of a sudden, insert at front became public, remove from front became public. Now this is the part that's really important you need to understand. Everything, what you're saying is, right? What you're saying is everything that I get from list should be placed into the public section of my class, me being stack. Everything from this class should go into the public section of my class. Okay, so that means technically I should be able to do this, correct? Because this is now public. Is this what you'd want? How about this? Is this what you'd want? You want this functionality? You want your stack to be able to do this?
No, because then it's not a stack.
Right. All of a sudden now, people will say, oh, you know what? This dude has remove from front, remove from back. They can start calling all of these functions. And the minute you can start calling all of these functions, stop calling yourself a stack. You're no longer a stack. You're a stack by name, but not by actual quality. You're not a stack. So if I make this public, this is the problem you're going to run into. There's another very important point I need to make. Even though right now you can do this, right? You see this? I can do this. I can do this. can I also do this? Can I also do this?
Yes, sir.
How many people say yes that I can do this line right here? How many people? The answer is come on, dude. What? I don't understand this little thing. Can't. This is wrong. This line is illegal. Who can tell me why this is illegal? Don't just say because it's private. That's not enough. It's not enough. Because you have to really now bring everything together that I've explained to you. Why is he still private? Didn't I just tell the compiler, everything you gave me from this dude, public, private, protected, everything, put it in the public section of my class. Didn't I just tell the compiler that? Why is this guy still private? I told the compiler, put everything that you get from this class into the public section of my class. So technically, he should become public. Right? Isn't that what technically what I'm trying to do?
Yes, sir. But since it was declared as private function before in the list part, so it not be private already.
Okay, and that's correct. This is the important point you have to get from this example. This is your recommendation to the compiler, right? You're basically recommending to the compiler. You're saying, everything that I get from this class, everything, public, private, protected, take everything and dump it into the public section of my class. Put it here. This is me. Put it in public section of my class. Everything, the public parts of list, the private parts of list, the protected parts of list. Take everything, put it in the public section of my class. So the natural line of thought would be, oh, that means if this guy was private inside of list and you put him in the public section of your class, then technically he has now become public, right? That's the natural assumption to make, right? That's the natural assumption. But the problem is this, and this is the one rule you have to remember, because the way they explain this thing is very complicated. You just have to remember one rule and one rule only, all right? You can never go from restricted to less restricted. You can only go from restricted to equal restriction or greater restriction. What do I mean by that? If something was private in here, if something was private inside of list, you cannot go from restricted, private, to all of a sudden public. You understand? You can only go to equal restriction or greater restriction. Because if that were possible, this would violate encapsulation rules. All right? This would violate the whole point, the whole premise behind having public, private, protected access specifiers would be violated if I could just go around and do something like this. So the point is this, the rule. You can only go, you can only go from restricted to equal or greater restriction. All right? So if something was private inside of list, when he comes into stack, can he become public? No. Can he become protected? No. Okay, so I think some people are misunderstanding protected. Protected sounds even more restricted than private. Let me show you the levels of restriction. Private is the highest form. followed by protected, followed by public. All right. This is number 1 in restriction. Number 2, number 3. Okay. So the rule is you cannot go from restricted to less restricted. You can only go from restricted to equal restriction. So for example, I had a function inside of the list class called get new node. That was declared as private inside of list. You said, take that function and everything else, put it in the public. This is what you had before, right? Put it in the public section of my class. Well, the rule says, hell no. If he was private inside of list, he will continue to be private inside of stack. That can never change. But you can go from, but you can always go from less restricted to higher restriction. So for example, if I put this back to private, if this is back to private, now what that means is that all those functions, insert, screw you. So if I have it back to private, that means insert at front, insert at back. All of these that were originally public. These were public inside of list. These are public inside of list. Now, because this is private, what you're doing is you can go from less restricted to higher restriction. So these are public, now they will become private. But if they were private, they can never become public. That's all you have to remember. You can never go from restricted to less restricted. Just remember that. You can never go from restricted to less restricted when you're doing inheritance. You can only go to equal restriction or higher restriction. So what the effect of this is? What is the overall effect of this? It's simple. Because you did this, now somebody can't just create a stack. Somebody can't do this. Somebody can't go, okay. Somebody can't go insert at back. The compiler would say, no. Compiler would say, no, you can't do this. This is private. You can't call this function. And they can't call insert to front. They can't call remove from front. They can't call remove from back. They can't call print. They can't call anything because it's private. But if you had made this public, then people can call this. And if people can call these functions, you can't call yourself a stack. So how do I get the things that I need? How do I get the things that I need from list, but prevent people from being able to call them? Well, I do inheritance, number 1, do inheritance, and number 2, restrict it so that the outside world does not have access. So 2 things. I want the things from this class, but I don't want people to be able to call them once I get it. So I do inheritance to get the things. That's number 1, do inheritance. Number 2, restrict it. Does that make sense? So now, if this is private, nobody knows about it, what do? Instead, I create my own set of public functions. So I create a public function called push inside of stack, right? So I create a public function called push, and look, inside of my public function, right? I call my private function. The outside world does not know about this guy, nor do they care. All they know is you have a public function called push. All they know is you now have a public function called pop. But notice, this guy calls insert at front, which is now part of the stack class. This guy calls remove from front, which is now part of the stack class. Similarly, is stack empty is public, so the world can call is stack empty, but under the hood, who does is stack empty call? It calls the lists is empty function. Similarly, the outside world knows that you have a public function called print stack. And who does print stack call under the hood? The function he inherited from the list class, which is print. So we just built a whole stack class using inheritance. Does that make sense what I just explained to you guys?
Yes.
All right, so that's it for today. I'm going to send you your program, your first program. It's going to be due next week. Not today's what? Tuesday. Next week, Thursday. It's going to be due next week, Thursday.
Same group?
Whatever groups you want.
How much?
4. 4 per group. All right, guys. So look out for that email with your program. And that's it. That's
So,
it.
sir, next week, Thursday, right?
Next week, Thursday, yes.
Okay.
Before
Alright, guys.
class.
See you guys. If you have any questions, let me know. All right. Adios.